Hi, good afternoon. My name's Layan.
And I'm Fatima Al Rubaye.
And we're here to represent GEMS AKIS. And we're going to be discussing how exactly we can use fractals geometry to aid in cancer detection. First things first, we're going to discuss fractals. So what exactly are fractals? Well, fractals are geometric shapes that repeat at different scales. Essentially, a fractal is a shape that no matter how many times you zoom into the shape, you will see that it's just a smaller version of itself repeated. Examples of fractals can be found everywhere, in nature, art, and even in medicine. Fractals can be represented by the recursive equation. A very well-known example of fractals is the Mandelbrot set. The Mandelbrot set is represented by the equation z equals d squared plus c. And we're going to see how exactly we can use this equation to test if the constant is within or outside of the parameter. Obviously, z will represent a complex number and c is a constant. So we look at the iteration bounds. When you take the formula, you have to replace the c value. Let's say we replace it with -1. We'll get a set that will continuously repeat the numbers -1, 0, -1, and 0. This means that this set will be part of the set. It will be bound within the parameter because it is maintaining the rule of -1 to 1. If we replace the c value with 1, we will get an iteration that will continue onwards to infinity, and that means it is out of bound or out of the parameter. The iteration bounds also work with decimal numbers, and we can see that in the example of 0.01.
Now, how do we relate this to cancer? Before I start, we should know that some cancers are curable while others are incurable. But what factor distinguishes these two? To begin with, most cancers are known to be incurable, and this is because they involve disruptions within their cell cycle, and therefore it causes the cell to continually grow. This dysregulation is often stemmed within their mutations in their genes, and this can be like the tumor reflector suppressor gene, sorry, and this will cause the key points in the cell cycle to dysfunction, and because of this, the cancers will continuously regrow and continuously divide. However, we should know that some cells, cancer cells, are curable. And this is because we can detect these early on through some radiation as well as chemotherapy. Now, chemotherapy is relating to fractals. And it's because, as Layan mentioned, fractals are basically just simply repeating shapes. And we know that when a cancer is incurable, it will continuously divide and continuously repeat. And therefore, when we are undergoing such a treatment, we're able to effectively determine where the cells are continuously dividing, and therefore we can take action early on.
So how exactly do we know when chemotherapy is working? Well, oftentimes researchers will take a sample, a cancerous sample, and place it under a microscope. Then they will take images of this sample and of a healthy cell that is regrowing and in the cell cycle, and they will compare the two through a digital software that will analyze through fractal geometry and the recursive equation how exactly these cells are multiplying. Thank you.
Thank you very much, Fatima and Layan.
It is indeed actually a very good point. I would like to say first, before I'd like to jump in and say something. Now, as an organization, you know that STEM best practice, we promote STEM education in the region, and we do a lot of programs and concepts like this across schools. But I've seen very few students take up core science as a subject, come with a problem, come with a solution for it. I really appreciate for that you taking up, because most of the time this kind of programs we see technology taking the first. But if you look at STEM, how it's handled, science is first, technology is second, engineering is third, and mathematics is fourth. So I really appreciate wherein we as an organization or a company or for that matter, we understood the importance of science when we were stuck with COVID, because we struggled to find a vaccine for 2 years. That is because lack of science education in school and lack of interest from students to pursue science or give science very importance. I'm so glad to see that a science concept you have introduced. You have come with a problem on a science concept, on a core science subject, and then you have come with a solution for it, and also something like a problem like cancer, and then trying to find a solution for it. I don't know whether you understand what I'm trying to say. We really appreciate that effort of both of you have taken in this and coming up with a topic or a subject like this, and really puts STEM in its place by giving science as the friend, because science is the leader, technology follows that, engineering follows that, and even mathematics follows it. That is why the acronym STEM, science come first. I appreciate Fatima for this effort, and your friend, both of you, very good job. I really appreciate this effort. Yeah, that's it from me.
Yeah, indeed, and it's different. So yeah, indeed, it's your work and idea is much appreciated. My question, is there any criteria or stage or time where that can be measured or non-measured, or it's applicable at all time?
It is applicable at most times, but it's important to understand that when why cancer is incurable is because cancer cells divide rapidly. They divide very, very quickly. Sometimes it becomes controllable to the extent you just give the patient a certain limit to live, and then you can't try with chemo. There is no way to actually stop it. So that's why we emphasize in the beginning that in order to make sure a cancer is curable, we have to make sure we prioritize early detection.
Yeah, okay. Thank you. Well explained. Yeah, thanks.
So thank you so much, Layan and Fatima. I don't have any question for you yet. I just want to say that this is very interesting, and thank you so much for tackling a scientific topic like this. Especially, it was very informative. You gave me new information, and I learned a lot from you. Thank you so much.
Yeah, I would agree. I think I've sat here for 10 minutes or so you've been speaking, and I've learned a huge amount. And obviously cancer is a huge thing that affects all our lives. Is it one in two people or 1 in 2 families will be affected by cancer in their lifetime? And yeah, your presentation was excellent. You spoke really well. A huge amount of knowledge for me. So it was a real learning for me. Again, I haven't got a question for you, but I just want to say I found that really, really engaging. So thank you very much.
Thank you.
Thank you very much, Layan and Fatima, for your contribution. Thank you.
Thank you so much.
Thank you so much.